We are given the problem to solve the differential equation d of y over d of x equals x squared over y when y doesn't equal 0, and then solve the initial value problem where y of 0 equals 3. So first we need to solve this differential equation, and to do that the first step is to separate the variables. So what I'm going to do is I'm going to multiply by y and multiply by d of x. So I get y d of y equals x squared d of x. And then we're going to take the integral of both sides. Next step is to integrate. And when we do that, we're going to get, remember when you integrate this, you're going to have y squared over 2 equals x cubed over 3. And then we only need 1 plus c, because even if we added 1 over here, it's still subtract and it equal the same. So that's why we only need it on one side. So now that we've done this, we need to separate. So what we're going to do is multiply by 2 on both sides, get y squared equals 2x cubed over 3 plus 2c. And then we've separated y from everything else, and we have the square, plus or minus the square root of 2x cubed over 3 plus 2c. So now that we have solved our differential equation, we need to go a step further and use our initial value of y of 0 equals 3 so we can completely solve it and find out what the c value is. So to do that, we just plug it in, and that means 0 equals plus or minus the square root of 3, 3, which is y, equals 2 times 0 cubed over 3 plus 2c. And 0 to any power is 0. So this all cancels out, and we get 3 equals plus or minus the square root of 2c. And so now we're going to square both sides, and that gives us 9 equals 2c, and c equals 9 halves. So then when we plug that in here, the 2's will cancel out, and we get y equals plus or minus the square root of 2x cubed over 3 plus 9. And that is how you solve differential equations.